So in this first question, in which species are the number of protons, neutrons, and electrons all different? What I would do is I would start by having this proton, electrons, and neutron kind of imaginary table without needing to use ruler. Okay, so you will notice that the number of proton is as I've put in blue dots there. There's number 9, there's 11, there's 15, and there's 16. Okay, and the number of electrons in an atom. So you got to remember, in an atom which has no charge, the number of proton equal to number of electrons when you have an atom. Here, when you have an ion, you have a -1 ion because you have one more electrons than proton. If you have a +1, that means you have one more proton than electrons. This is an atom. This is a 2- because you have gained 2 electrons, you have 2 extra electrons than protons. So here is 16 plus 2, 18 electrons. Remember, this is proton, electrons, and neutrons. So this is an atom, so it's 15 electrons. This is a cation, so it's lost 1 electron, so it's 10. This one has gained 1 electron, this is 10. The number of neutron, on the other hand, is the number of nucleon. So the one on top is called nucleon. Number is the number of protons and neutrons in an atom, in the nucleus of an atom. So 19 minus 9 give you 10 neutrons. 23 minus 11 give you 12 neutrons. 31 minus 15 give you 16 neutrons. 32 minus 16 give you 16 neutrons. All right. So we want all different. Okay, we don't want all the same. If you want all the same, well, none of them give you all the same. All right. Well, I guess there are some. So here, these two are the same. Here, these two are the same. Here, these two are the same. Okay, so you want all of them to be different. Well, they're all different, 10, 11, and 12. All right. Next question. Which one contains that much oxygen atoms? Be very careful, yeah? Atoms. All right. So the formula, aluminium oxide is Al2O3. You learn electrolysis of Al2O3 from GCSE and O-level. So you can't say you can ever forget that, all right? Plus, it's also an oxide of third period, which is part of the A-level case study. Sulfur trioxide is SO3. This is H2O. So here you have 3 oxygen atoms. Here you have 2 oxygen atoms. Here you have 3 oxygen atoms. Here you have 1 oxygen atoms. Okay. So this is mole of the whole thing. Okay. So you got to compare the whole thing is to how many oxygen atoms. 1 mole of this has 3 oxygen atoms. 1 mole of this has 2 oxygen atoms. 1 mole of this has 3 oxygen atoms. 1 mole of this has 1 oxygen atom. Okay. But you have 0.25 mole, so it's got 0.25 times 3, because there's 3 oxygen atom in 1 mole, but you only got 0.25 mole, so 0.25 times 3 is 0.75. 0.75 mole times 2 oxygen atom, that is 1.5. 1.5 times 3, that is 4.5. 3.0 times 1, that is 3.0. These are all mole of oxygen atoms. I'm not looking at molecules, I'm looking at atoms. All right. Now this is 9.03 times 10 to the 23 oxygen atoms. This is mole. This is mole. So what I do is I can convert each of these into number of oxygen atom by multiplying by Avogadro constant. So times Avogadro constant, times Avogadro constant, this and this as well. But instead what I'm going to do is I'm going to convert this into mole. So the mole of oxygen atom is equal to 9.03 times 10 to the 23 divided by Avogadro constant given in your data booklet. Your data booklet shows Avogadro constant as L. That is your Avogadro constant. It's the number of atoms present in 1 mole of the atoms. It's the number of ions present in 1 mole of the ions, etc. etc. Yeah? So I get 1.5 exactly. So that is the mole. And the only one that gives me 1.5 is this one. So I can be sure that the answer is B. Like I said, converting each of these into, by multiplying by L, is going to give me a lot of numbers with 10 to the 23. I may as well convert this into mole by dividing by Avogadro's number. Then I can just compare number of mole, right? Question 3 is about balancing a chemical equation. So you have powdered aluminium, powdered barium nitrate. You get an unreactive gas. That is 1. You get all nitrogen atoms are reduced. All nitrogen atoms are reduced. You started from barium nitrate, which is Ba2 plus NO3 minus. So the 2 plus and the minus 1, the lowest common multiple is 2, so you need 1 of it and you need 2 of it. That's why the formula you see is barium 1 and nitrate twice, barium 1 and nitrate twice, alright? So what happened then is, this is NO3 minus. The overall oxidation state of the NO3 minus is minus 1, because we don't care how many you have, we just care about each individual unit has a charge of minus 1, is equal to the nitrogen plus 3 times minus 2, because you have 3 of the oxygen, each of which is minus 2. Nitrogen is minus 1 plus 6 is plus 5. So you started from nitrogen plus 5 here. All the nitrogen atoms are reduced. Here you get barium oxide and NO. You have an unreactive gas. NO is a reactive gas. So not A. Between these gases, N2 and O2, I would say N2 is the more unreactive because of the strong nitrogen-nitrogen triple bond. It needs very high amount of energy to react. As you would know, they will only react when in your car engine, okay, very high temperature, or in nature when you get a lightning, only then the nitrogen can react with oxygen in the air, alright? So I would not be tempted to think B is the correct one, because O2 gas support combustion. So O2 on its own is doesn't do anything, but it can react with many other things. Yeah. In terms of C and D, what I can say is it's not D, because here you still have NO3 minus, you still have Al3 plus. That's why you need 1 of these and 3 of these, okay? But if you read the question, all nitrogen atoms are reduced. You started from nitrate, you still end up with nitrate. That means your nitrogen is plus 5, it's still plus 5 here. Not all the nitrogen atom has been reduced, not following the instruction. So has got to be C, where there's no more nitrogen left in the plus 5 oxidation state, because everything got reduced to this unreactive nitrogen gas. Question number 4, they ask for which one has the highest boiling point. These are all simple molecular structure. I could tell by looking at the molecular formula. They have molecular formula because they are simple molecules, okay? Molecular formula is defined as the actual number of atoms in one single molecule. So each of these can exist as a single molecule. Therefore, we need to think about break intermolecular forces, alright? If you are doing this, if you're doing this full paper, you would have done something on organic chemistry. You will have touched on skeletal formula, so that's why I can afford to do this. If you are doing this in a theory, in a topical MCQ, I probably wouldn't touch on this yet because you might not have done skeletal formula. So browse through the channel for some topical MCQ playlists. I think I've got 3 playlists now, about 10 questions in each playlist for each and every single topic listed in A-level chemistry. So by doing that, you will have access to hundreds and hundreds more MCQ. They are sorted out by topics, and for me personally, I think that's more useful than a full paper tutorial, because if you feel confident enough, then you should do one full paper on your own, based on all the strategy that you have learned from my tutorials, and you should do much better. If you keep on doing yearly paper, you will run out of paper which you have never seen, and therefore you will not be able to tell how you will score in the real thing, okay? Because you don't just practice and then just do the actual deal itself. No, yeah, you need to spend some time and actually do a full paper which you have not done before, hopefully, okay? So that's why I say going through the topical MCQ first might be a better idea, okay, before you go through a full paper tutorial. So going back to this question, there's option A, and then option B is the straight chain, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So these and these are isomers, 1, 2, 3, 4, 5, because they have the same molecular formula. They're both alkane, but this is a straight chain. So what you can imagine is you can have another straight chain, and this thing can get close to each other. So the van der Waals is stronger because the surface area is bigger. Okay, so this has a stronger van der Waals than this because this is branch, when you branch out, this thing occupies space. You can't get so close to each other. Another molecule of this cannot get too close to this. Compared to these straight chain, they can get much closer to each other due to the bigger surface area. Okay, so it's got nothing to do with the total number of electrons because they have the same molecular formula. The moment you start talking about this one has greater number of electrons, then you already mess up already, especially in a theory paper, because these are isomers. They have exactly the same molecular formula. Therefore, they have exactly the same number of electrons. Therefore, talking about that means you don't know what you're talking about at all. Alright? Anyway, so those things will only be van der Waals. Okay, so they are not the strongest of all. Usually we don't really talk about them in the context of this question, because here we can see there are some more stronger intermolecular force. If I draw C, you will see that there is a ketone and you have permanent dipoles. Okay, and permanent dipoles are stronger than van der Waals. And of course the last one, I hope you can see, that is alcohol. And you have an oxygen bonded to a H, so there's lone pair on the oxygen, there's delta minus on the oxygen. You can show the dipoles, you can show another alcohol molecule like this, like this one, and then you can show the attraction from the lone pair to the H delta plus of another molecule of this. This one can form H bond. This is the one that will have the highest boiling point because of the strongest intermolecular force, the hydrogen bond to break. Okay. Number 5 is an ideal gas question. I guess you have to assume that it's ideal gas. You have a sulfur vapor, so there is a gas. We don't know the molecular formula, so it could be any of these. So we need to let the MR, be the MR, I guess. So we're given the volume. The volume is in meter cube, that's good. The temperature is in Kelvin, and that's good. The pressure is in Pascal, that's good. The mass is in gram, that's good. Okay. PV equal to nRT, where N is the mole of the gas. The mole of the gas you can relate to the mass over the MR of the gas. We want the MR of the gas, so it's MRT over PV. Your M is 0.321 gram. Your R is from your data booklet at 0.31 joule per Kelvin per gram, per mole, sorry, not per gram, per mole. Your T is 2500 Kelvin. Your P is 1.00 times 10 to the minus 4. Your V is 2.08 times 10 to the 6. Put all that into your calculator. So no need, once I write all of them down in the correct units as required. So this is Pascal, this is meter cube. So I got 32.06, and I know that for one sulfur, the atomic weight is 32. So I get the molar mass, the molecular weight of the sulfur vapor is just for one sulfur. So the molecular formula for the sulfur is just sulfur, just one of it instead of having any of these, yeah? Because this is exactly the mass of 1 mole of sulfur atoms. Number 6, which reaction involves a decrease in the bond angle at the carbon? If we have number A, you have bromoethane, you reflux it with ethanolic sodium hydroxide. So what we'll get is we'll get elimination. We don't get hydrolysis, we get elimination of HBr. So there is your HBr. You will go there and there. You will eliminate HBr, and then you will get a double bond like this. You go from a carbon sp3 to a carbon sp2. There's 120 degree, there's 109 degree. That is an increase from 109, okay, because you carbon bonded to 4 groups, sp3, carbon bonded to 3 sigma bonds only, okay, each carbon. So there's 180 degree carbon sp2. Number 2b, I wouldn't go to write the whole equation, but you have CH4 going to CO2. Hope you know CO2 is carbon sp, 180 degree, linear geometry. This is tetrahedral carbon sp3, 109 degree. Okay, So again, 109 to 180, there is an increase, not a decrease, all right? Ethanol heated with corn sulfuric acid, so that is elimination of H2O. So because you're eliminating H2O from ethanol, so I hope you can see that that is ethanol going to that plus H2O. So we have the same issue, carbon sp3, 109 degree tetrahedral, carbon sp2 in the alkene. When you have alkene, you have carbon sp2. You can look through my topical playlist for concept of hybridization if there's something you're still very weak at. So go through that tutorial in the structure and bonding topical playlist, all right? So it's carbon sp2 because each carbon is bonded to 3 sigma bond, okay? Here each carbon has 4 sigma bonds, so 4 bond pair and 0 lone pair. Here's 3 bond pair and 0 lone pair. That is 120 degree there. So again, there's an increase, which leaves us D as the correct answer because all 3 are incorrect based on what we want. When we have polymerization of ethene, we would have, I guess I can draw it out. We started on carbon sp2 120 degree ethene, and then we end up with ethane. Sorry, we don't end up with ethane, we end up with the polymer, which is polyethylene. There is no more carbon-carbon double bond, but each carbon is now bonded to 1, 2, 3, 4. Each carbon is bonded to 1, 2, 3, 4. What you have is carbon sp3 109 degree. What you have previously was carbon sp2 120 degree. Okay? Question 7. So we know that nitrogen and oxygen only reacts in the car engine because there's a very high temperature, enough to break the very strong nitrogen-nitrogen triple bond, which has a very high activation energy. Yeah? So we know that it's endothermic. So from the reactant, so this is incorrect because enthalpy change is from the reactant to the product. So that is the enthalpy change, and that's less than 0. So that is incorrect. Enthalpy change from the reactant to the product, that's endothermic. So that's fine. That is from the reactant to the product, that's endothermic, that's fine. That's greater than 0, endothermic, that's fine. Okay. So that's the first bit. The second bit is activation energy. Is from the reactant to the top of the peak. This is not the activation energy of the reaction. What you will get is actually should be, oops, sorry, I don't want to overlap that. Okay, should be from the reactant to the top of the peak. All right, so B is out. B is out. Activation energy from the reactant to the top of the peak. So activation energy is fine there. Activation energy has direction. It's from the reactant to the top of the peak, not the other way around. Okay. So there's only one correct answer there. The reaction is endothermic. The activation energy is correctly labeled. Question 8. So we have a reaction sequence here. This is about, well, it's not really about the production of H2SO4, but anyway. So sulfur there is +4 because SO2 overall has no charge. Sulfur is what you want to find. -2 for each oxygen. Sulfur is +4. You can do the same. I leave it as exercise for you to work out sulfur +6 for SO3. Something you will need to do for the oxides of period 3 chemistry anyway. Something you would be expected to have achieved by the time you finish this AS syllabus, which was generally what you cover in redox changes, which was generally what you cover in general periodicity, which is also what you recovered in nitrogen and sulfur chemistry. Okay? H2SO4, you know that consists of SO4 2-. There's also sulfur +6. You deal a lot of this with group 17 chemistry when you react halide with corn sulfuric acid. So you would have needed to know that this is sulfur +6. Sulfur -2, sulfur +4. Okay? So overall what we can say is +4 to +6 is oxidation. +6 to +6 is no change. +6 to -2 is reduction. -2 to +4 is oxidation. So 1 is oxidation, 2 is no change, 3 is reduction, and 4 is oxidation. So C is the correct answer. Number 9 is to do with equilibrium because you have reversible reactions. So given the partial pressure H2 and CO2 are both 10 kilopascal, and you know the Kp. What is the partial pressure of CO? Okay, so if you have the partial pressure of H2 and the CO2 above 10.0 kilopascal, so the partial pressure of CO is actually equal to the partial pressure of H2O because of the 1:1 ratio. Both of these are product. Alright, if you produce 1 mole of these, you also produce 1 mole of these based on the stoichiometric equations. So therefore, let them be X. So you will have Kp is equal to PH2O, PCO over PH2, PCO2. What you would have then is if I let that be that, then Kp is 0.288. PH2O is X times X divided by 10.0 times 10.0. So I get X squared equal to 0.288 times 10.0 squared. So X squared equal to 28.8. What is X? It's the square root of 28.8. You get 5.4. Well, maybe I shouldn't run up too much. 5.367. Okay, so that is kilopascal, and the closest one to is 5.37 kilopascal to 3 sig fig. Okay, and what is X? X is the partial pressure of CO, which was equal to partial pressure H2O, which we set it to be X, which we already calculated.